From the public lectures that were offered to us at Georgia Tech this semester, I have chosen to speak on a lecture given by Professor Matsumoto. She spoke on the geometry of weavables, wearables, and wallpaper. I found this talk specifically interesting because of the manner in which she presented her findings. She began by simply talking about the different types of symmetry that not only appear in man-made items, but also occur naturally in the real world. This is a concept which we have all been familiar with since we were in kindergarten, but Professor Matsumoto's talk was unique because she was able to explore such a common topic and break it down into its basics in a way that the audience would be able to see how it related to the real world and physics. On the first day of any physics class, a professor will typically begin by explaining to the class why physics is useful. Often, if some students don't want to take it, the professor will explain how its concepts are necessary for all of us in ways that we have never considered, simply to live out our daily lives as we know them. I believe that Professor Matsumoto's lecture was a perfect example of this. She was able to show us how a concept such as symmetry, which we all take for granted, simply accepting it without thought, is a naturally occurring phenomenon that can be explored deeply using physics. What really grabbed my attention during this lecture was the concept of adding and subtracting sides from a pattern, or, as Professor Matsumoto described it, creating a shape with either positive or negative curvature. She was able to do this in such a way which resulted in a three-dimensional shape with an interesting spin on symmetry. By understanding the concepts of 3D space that we have learned in Physics 2, it was much easier to grasp onto these concepts. I also found it interesting how Professor Matsumoto was able to mix together both physics and geometry in her lecture. She very clearly explained to us how many of the two-dimensional rules of geometry that we learned in high school could be applied to three-dimensional shapes. She also combined all of these concepts together in a beautiful example in which she had a two-dimensional plane made up of hexagons. At one point in the plane, she removed one of the sides of the hexagon, creating a pentagon. However, in doing so, she created a point of negative curvature on the plane, which was actually no longer a plane. Then she performed a similar maneuver, but with adding a side to one of the hexagons, creating a heptagon. In this instance, she created a point of positive curvature. What I found truly interesting was when she took this new shape and showed it to the audience from a point of view of the original plane, so that we could look onto the object as if it were still a plane. This unique perspective was able to show us how by adding and subtracting sides from the hexagon in the plane, we were able to morph our view of two originally straight red lines so that we could view them as if they were going straight for a while, and then when the plane went up, they would then suddenly be wider apart, which when we just viewed it as a flat plane, we were not able to see this difference. She then was able to show us how this example could then be further related to a real-world example of making a dress. I believe that this was the perfect example for her to use to explain the theoretical points that she brought up. However, a question that I did have for her that I was not able to think of until after the public lecture, so I was not able to ask her, was if humans developed all these different types of symmetry from the various items that we find in nature that are naturally occurring, or if we as a species were able to create this concept in our mind without knowledge of how it worked in all these crazy ways all around us. I believe that we have taken this idea from different pieces of nature, but as Professor Matsumoto mentioned several times throughout the lecture, the human mind is somehow wired to pick up patterns. If this is so, maybe we were able to develop these ideas from a blank slate as well. I want to thank Professor Matsumoto for a wonderful and interesting talk, which really allowed me to think about a concept that I have often taken for granted, which is, funny enough, how I used to think of physics until I recently began to realize that whether you realize it or not, physics is truly all around us.